Hey guys, welcome back. Another tutorial here today. Today I'm going to discuss a simple anti-debugging trick. It's really simple, it's easy to bypass, but it's also equally easy to implement, and it's a good way to trick, the most basic of reversers who are trying to access your code that you don't want them to have access to in your binary file. Before we get started, I want to show you a system call under Linux. It's called ptrace. So ptrace stands for process trace. The ptrace system call provides a means by which one process, the tracer, can observe and control the execution of another process, the tracee, and examine and change the tracee's memory and registers. It is primarily used to implement breakpoint debugging and system call tracing. Now, hearing that description, you can infer that this plays a large part in building debugging tools like GDB and other debugging tools on Linux, which it does. I mean, GDB is built on top of ptrace. So if you can somehow detect that ptrace is being used in your program, then you can detect that you're being debugged. And there actually is a very easy way to detect ptrace, and I'm going to show you that today. And then I'm going to show you how to defeat it, which again is very simple. This isn't advanced stuff. At some point I hope to actually get into more advanced stuff, but right now I'm just showing you guys, kind of giving you a basis to kind of build on. So we're working with our login program still. We're going to actually include the ptrace header file. I believe it was that. And we're going to do a call to ptrace, declare a variable called the return value. Ptrace trace me. So what this does is it calls ptrace, and it calls it with this enum ptrace trace me. And what that means is it's going to trace itself. You don't have to worry with the other arguments. Now, the way to detect if ptrace is being used on your program or if it's being debugged is ptrace will actually return -1 if it's already being debugged. You can't ptrace the same process. So if return value is less than 0, we know that we're being debugged. We know that ptrace is being used on this process. So we can do something like, no debuggers allowed, and return -1. So again, we're calling ptrace on ourselves. If it returns -1, so less than 0, we know that we're being debugged. Someone else has already called ptrace on this process. So if we know we're being debugged, we want to avoid, we want to do everything we can to avoid them getting into our binary and the rest of our protection scheme. So we're going to exit right at that point, so they don't even get the rest of the program flow. They don't get a chance to crack it after that point. So let's save it. I'm going to compile it and run it, and we'll see how that works. So let's run it normally without a debugger. It still works as you would assume. But now let's run it underneath GDB. Let's set a breakpoint on fgets. This is how we cracked it in the first iteration. We knew that we were inputting data, so we did a breakpoint on fgets to try and trap where our data was and follow it and see where that compare was made. So let's run the program. And as you would expect, it says no debuggers allowed. So it detected right away that we're debugging under GDB, and it didn't continue the program. So we never actually got that fgets call, and we can't see our password because there's no password actually entered in at this point. And we won't ever see the actual the real password, because it never actually gets to the point where it actually decrypts that password. So now I'm going to show you how to crack this ptrace detection. Now again, we wrote the program, so we know it's using ptrace. Right away, I know it's using ptrace. So we're going to do a break on ptrace, run it, and now you see you break in. We break into the ptrace system call. Now I'm going to do finish. Just so you know, I don't think we've gone through finish yet. Finish will actually finish the current call and return to the line of execution after that call. So I should be inside of our main code once I hit finish. And there you see I break back into main. And let's examine the instructions. Again, examine 10 instructions from our current instruction pointer. So this is the call. This is the line right after our call. Now you can see what it's doing here. Again, most of you guys maybe don't know assembly. I'm not that great at assembly either, to be honest. But you'll see here it's moving the value that was returned. Return value is always stored in EAX in that register. So it's moving the return value into this memory location, the base pointer minus 1C. And then it's going to compare the value. And then it will jump if not signed. Now, jump if not signed, basically it will jump. It's looking to see if it's a negative number or not. So what happens here is, we know it's -1 because it's being p-traced. So if it's not signed, so it's not a negative number, it will jump into the good code. If it is signed, it's a negative number, it's going to go here and put out, no debuggers allowed, and then eventually exit the program. So what we're going to do is we're actually going to make, there's a couple ways we can actually fix this. What we're going to actually do though is we can actually make this jump always. So change the JNS to a JMP so that it's not a conditional jump, it's just unconditional jumping. We can change the compare. We can change the value here to set it to 1 or 0 or what have you, any kind of not signed integer. There's a lot of ways we can actually fix that. I'm going to fix it right here. I'm going to set EAX to something. Let's go set EAX for 1. So now what's going to happen, I've changed the return value. I've set EAX to 1, so then it'll move 1 here instead of -1. And if I hit continue, we should be good to get past that check. So now it asks for the password. It's actually breaking because we have breakpoint fget, so let's continue again. Hello. Access denied. So you can see that we got past that debugging check. Now, what if you didn't know that it was ptrace? So I mean, again, we've coded this program, we know what's going on, but generally what will happen is it'll be something like this that'll happen. Most authors aren't going to tell you right away, hey, I detected your debugger. No, all they're going to do is something like this. They're not going to give you a message, saying, hey, I know you're debugging my program, you can't do that. They're going to just exit silently. That wasn't what I expected. Let's see, what did I do wrong? Oh, I'm not being debugged. Okay, so again, if we run it, that's what's going to happen. You're not going to get any kind of indication that he detected your debugger. You're just going to exit and you're going to think to yourself, like, what's going on? This program doesn't do anything. So you're not going to know right away that it's ptrace. I mean, you can set a breakpoint on ptrace and just check, because you know that technique now that I've introduced it, and you obviously know now that will be it. But again, if you starting from scratch and you have no idea what's going on, it's just going to exit with no message. So what you'll do is you'll break in at the original entry point, the entry point of the file that I showed you how to get before, which is right there, 400560. Then we'll run it. So we'll break in at start. Now remember, we're going to do disassembly here of 20 instruction, because again we want to get the address, which will be right here, of our code. Check my tutorial number, I believe 3 or 4, which will explain this process of breaking in at the entry point and then getting into the main code. Then we're going to continue. Now we're going to disassemble it again, 20 instructions, from the instruction pointer. Now here you get an idea. Now you can see, this is our stack frame, and you can see the call to ptrace, and you say, oh, okay, I see what they're doing here. They're calling ptrace, checking for -1, and if it's -1, we know they're being traced, and it's going to exit silently. So again, that's just the way, if you have no indications, you want to break right at the entry point, that's what you would do, and then follow the code, and you detect, what's actually going on. Now, another thing you can do, another tool is called ltrace. Basically what it does, it'll trace library calls. So if we do an ltrace on our login, you'll see one system called ptrace return -1 and it exited. So again, because you know that anti-debugging trick that I taught you here today, you'll know right away that that's what's going on. There's another program called strace. Strace is a little more in depth. It will trace system calls as well. So you'll see a little bit more output here, but you'll see basically the same thing. So you see here, I mean, again, it's a little more output, a little more verbose, a little more low level. So executing it shows you all the access to the LD preload, what have you, checking for LD preload, and then but eventually you're going to see the ptrace returning -1, not permitted because we're already debugging it, because ltrace and strace both use ptrace as well, and then exiting. So that's just an easy way to detect a debugger if you ever want to actually include any kind of protection in your binary. Again, it's very simple. There's much more advanced techniques out there nowadays, but this is one of the most basic. There's a lot of other ones. For example, another thing you could do is you can actually look for it, read all the process on the system, look for GDB in it, in your process tree, and then if you see GDB, just don't run. Again, that's easily defeated. I mean, they can rename GDB to whatever they want, but it's all about being sneaky and trying to detect it without the person running your code knowing that you're detecting the debugger. But eventually what's going to happen is, a skilled reverser is going to break on the entry point of your program. He's going to follow the code, and I mean, it's hard to hide exactly what you're doing at that point. So I hope you like this tutorial. I'm going to write some more, hopefully release some more this weekend. Thanks a lot, and have a good day.